Trigonometric ratio of complementary angles. So we would like to understand what are complementary angles first. Two angles are said to be complementary if their sum is equal to 90 degree. One way to visualize this is draw an angle of 90 degree. And when we divide this angle in two parts, like that, those two parts could be small or big, doesn't matter. So you simply divide this angle in two parts. Now the two angles formed are complementary. Now we can represent these angles by letters, say theta and phi. So theta, this letter theta is a Greek letter. We pronounce it theta. And another one, this is also Greek letter. This is phi. So theta and phi, in this case, we can say theta plus phi will always be 90 because we are actually dividing that 90 degree in two parts. So however small or big these parts are, their sum is always going to be 90 degree. Another way to visualize these complementary angles is a right angle triangle. So we are going to draw a right angle triangle here. Let's say this is a right angle triangle. And we can name this triangle as, say, A, B, and C. One of the angle is 90 degree. Here it is 90 degree. Let's say angle C is theta. Angle C is theta. Then angle A in terms of theta we can find. We know the angle sum property of the triangle, that the sum of three angles is always equal to 180. If one of them is 90, that means sum of other two is going to be, sum of these other two, A and C, is going to be 90 degree also. So we can write here that angle A plus angle C will always be 90 degree. Now, if angle C is theta, then angle A can be written as in terms of theta this way. So your angle A is 90 minus theta. So can we write here in this place that this angle is 90 minus theta? Now we will write trigonometric ratio for angle A and angle C, right? Angle C is theta and angle A is 90 minus theta here. This angle is 90 minus theta. Now we have already learned Sohcah. We write these trigonometric ratios by Sohcah. This says sine is opposite by hypotenuse, cos is adjacent by hypotenuse, and tan is opposite by adjacent. For this angle theta, let's write sine of theta. So sine of theta, theta is angle C. In right angle triangle, we already know the hypotenuse is the side opposite to 90 degree. And for this theta, this is opposite side is AB and adjacent side is adjacent and opposite. So we can write sine theta now. Opposite by adjacent means AB over opposite by hypotenuse. That means AB over AC. Now what would be cos theta? Cos of theta, cos is adjacent, that is BC, divided by AC, hypotenuse. This is cos theta. What about tan theta? TOA, opposite by adjacent. So this is going to be AB over BC. Sine cos tan is written, and other three trigonometric ratios which are reciprocal of these sine, reciprocal of sine is cosec. So we can write cosec theta would be reciprocal AC by AB. AC divided by AB. Now sec theta would be reciprocal of cos, that is AC divided by BC. And finally cot theta can be written as reciprocal of 10, that is BC up, AB down. So that is BC divided by AB. Right, so these are the trigonometric ratios for angle C or theta. Now can we write trigonometric ratios for this angle A also? For angle A, let's write it. Our opposite side and adjacent side going to change. Look, opposite side would be, here is for angle A, you just take away this angle A, its opposite side is BC. This is opposite side. Okay, now this becomes opposite, and then AB would be adjacent. That is only the difference. Rest we can write the trigonometric ratios for angle A, angle that means 90 minus theta. So we can say sine of angle A, which is 90 minus theta, sine of A would be opposite by hypotenuse, that is BC divided by AC. Similarly, we can define cos of 90 minus A, 90 minus theta. Cos of A we are saying, right? And the angle A is 90 minus theta. So that would be cos for this angle is adjacent by hypotenuse. So we have AB over AC. And we can write tan 90 minus theta also. Tan 90 minus theta would be 10 for this angle A, which is opposite by adjacent, is BC divided by AB. Now other three trigonometric ratios, of course, they are reciprocal. So we can say the cosec of 90 minus theta, cosec of 90 minus theta. When we are saying 90 minus theta, that is 90 degree minus theta. Okay, the degree is in every one of these. So cosec 90 minus theta is the reciprocal of sine here, which is AC by BC. We just make it upside down, AC divided by BC. And okay, sec of 90 minus 90 degree minus theta, that means reciprocal of cos. Cos is here, so AC by OAB, AC divided by AB. And finally sine cosec and then cot. Cot of 90 minus theta means we would like to find cot of angle A, that is reciprocal of 10, means AB over AB, reciprocal of 10, AB over BC. Now if we look at these two columns, what do we observe? Like here we have AB over BC. Here you see AB over AC, and AB over AC is this, right? Also, this is the second one, BC over AC, and BC over AC is this also. So what did you observe? Can you equate these two? Can you say this and this are same? Similarly, can you say these two are same? Well, I think you can. Here you see AB over BC, this one, AB over BC, and here also you have AB over BC. Is that AB over BC? Cosec 10 and cot. Okay, AB over BC here and AB over BC here. So AB over BC and AB over 10 90 minus theta means tan theta is same as cot 90 minus theta, and similarly cot theta is same as tan 90 minus theta. Look, BC over AB, BC over AB. And finally, we have one more, that is sec of 90 minus theta, which is AB over AC over BC. Here it is. Sec is related with cosec, and cosec is related with sec. So can we write this in order now? Yes. Let us write all these in organized manner. So we can say Sine of 90 minus theta. Okay, can we write them here? Okay, just take away this, and in place of yes, we can rewrite these all, and we can say sine of 90 minus theta is going to be cos theta. Cos of 90 minus theta is sine theta. Tan of 90 minus theta was same as cot theta. Cosec of 90 minus theta was same as sec theta. And sec of 90 minus theta was cosec theta. And cot of 90 minus theta was tan theta. Now, if you observe with little carefully, you will see cosine and sine, they are complementary. Tan and cotan, right? Cot in short we write. So tan and cot are complementary. Yes, and they are related in complementary relationship. Now sec and cosec, either you add CO or you take away CO, right? In these all 90 minus theta formula. So this is very easy to memorize. So whenever you are using 90 minus theta or the complementary angles, so if it is sine 90 minus theta, you don't need to do much, simply add co. And if there is already co, remove that co. Cos means co, this is abbreviation for cosine. So we just simply take away co, it is sine. Cos of 90 minus theta is sine theta. So these are the 6 complementary angles and the formulae for the complementary angles, and very easy to memorize it, and we will apply this in some of the question. Let's see one example based on this, right? Suppose you are asked to find the value of sine 25 degree divided by cos of 65 degree. Now, you neither know the value of sine of 25 nor of the cos 65. And you also don't need to know these values. You can find the ratio using these complementary formulae. So what we are going to do is, let's keep one of them as it is. Say sine 25 is 25 only. And in place of cos theta, we had the identity, you know, cos theta can be written as sine of 90 minus theta. We are applying this formula, okay, to change one of them into the other. So cos of 65 can be written as sine of 90 degree minus 65. So what is 90 minus 65? 90 minus 65 is 25 sine 25 degree divided by sine 25 degree. Now these two can be cancelled, same terms, no? You get 1. So look, you can calculate trigonometric ratios like this without actually knowing the value of individual ratio using these complementary angles. So that's all for now. Thank you very much for watching. See you in next presentation.